name is Sean McGee, and this is my storyboard screencast into the Baird production management system. This document is split into three sections. The first section deals with the research that I conducted throughout this project. Section 2 deals with the inputs, processes, and outputs associated with the system. And Section 3 deals with the coding approach that we envisioned we would take to complete the project. During the research phase of the project, I looked at research about the company, research about the company's printing presses, the software that the company uses, the calculations that may be needed to complete some of the processes, and research into some of the measurements that are going to be used throughout the project. First of all, we looked at the company. We looked at the pre-press stage, and the software used in the pre-press stage is Kodak Insight, and that is a pre-press software program. We also looked at the printing and the printing presses that the company have, and the company's quality control. We took an in-depth look at what is involved in the Kodak Insight software program and how it blends into the current company databases. And then we took an in-depth look at the printing presses, like the Rapida 105 printing presses, the specifications, the technical specifications of this printing press and what is involved in it, as well as the Speedmaster SM102 printer and the HP L26500 digital printer and the Xerox 700 digital printer. After that, I had some contact with the company through the company representative. I sent them an email outlining some questions about various issues regarding the project, such as do the employees currently have identification numbers, do the printing presses currently have identification numbers, is there scope to add a screen which would be visible to the entire production flow. So there was a number of questions that I had regarding the project, and I sent them on to the company representative. The company representative then replied in a detailed answer. They replied to my questions. For example, to the question, did the company currently have identification numbers for employees? Yes, it's a 4-digit numeric code. So that automatically answered some of the issues that I had to deal with throughout the project. Next, I looked at some of the equations and some of the tricky equations that are going to be dealt with throughout this project. And the first one is the ability to convert the ink usage that we have, which is being measured in milliliters, into an actual weight in order to measure our rejects. And to do that, the major variable that's involved is the density of the liquid. So one of the things we're going to have to do is go and find out the density of all the inks that are being used at the company. Once we find that, we can multiply that by the milliliters that are being used, and this will give us a result of grams, which will show us the weight of the actual ink being used. Next, we looked at the energy consumption, and we can see that the general energy consumption calculator shows us that the energy which is recorded in kilowatt hours per day is found by multiplying wattage by the number of hours of days the wattage is used and dividing that by 1,000 to show the actual kilowatt hours in a day. Next, we move on to our input, processes and output sections. In this section, we look at the key inputs into our system, the database design, the processes that we need to complete on these inputs, and the outputs that happen once these processes are complete. So in our input stage, we have an entity relationship diagram of the database that we have constructed. It is a 12-table database with multiple entries. It has various different tables to hold the key elements, which are all visible in this diagram. We have created a lot of relationships in the database in order to manage the flow of data and the connection of data. This will help us to process a number of computations throughout the system and help us maximize the potential usage of the data that we are storing. Some of these processes that I was talking about, first of all we have to look at the rejects and how to calculate the actual amount of pages that were left to be produced on a run. So the first thing we had to do was to calculate the number of rejects from a bulk weight. We done this by using the ink per job and ink tables to find out the total amount each ink used in milliliters and multiply that by its density to find the combined weight of the ink used on a sheet of paper. We can call this ink weight. From the paper table then we used the paper weight variable. From the reject table we can get the latest current scale weight and subtract that from the previous current scale weight to give us a rejected weight. This is the weight that we are actually going to look at, the current rejected weight of the sheets of paper. So we can then add the ink weight and the paper weight, divide it by the rejected weight, divide that into the rejected weight rate, and we will get the number of pages that are rejected. From the printer counter table then we can use the current count, and from the job table we use the quantity, and we can then figure out that the job quantity minus the current count and minus the number of pages rejected is equal to the amount that is left to produce. We then moved on to look at how we could actually plan and show our planned ink usage versus our actual ink usage. Calculating the ink usage is done by taking from the ink job table the sum of the total millimeters of ink in a job, and that will give us the ink per page. From the printer counter table we use the current count variable, and then using the same principle as the reject calculations we can get the number of reject pages. So the current count minus the number of reject pages multiplied by the ink per page can give us our planned ink usage. The current account multiplied by the ink per page gives us our actual ink usage. We can then create graphs to show the two of these trending against each other. The same principle is in play for the paper usage. From the printer counter table we use the current count, and this is simply the current count minus the number of reject pages is equal to the planned paper usage, and the current count actually equals the actual paper usage. For our energy use is a slightly more complicated process to calculate. The printing press is currently saying the energy consumption in kilowatts per hour every 15 seconds to the database. Unfortunately, this is a speed rather than an actual consumption. In order for us to calculate the actual consumption, we need to make the assumption that the speed does not change during that 15-second period. This is important because if the speed was to change, or we were to assume the speed had the ability to change during that 15-second period, we would not get an accurate readout using our calculations. So the actual energy used in a 15-second period is calculated by taking the kilowatt hours, dividing that by 3600. This gives us a kilowatt per second reading, and if we multiply that by 15 seconds, that shows us our kilowatts actually used in that 15 seconds. Once we have that information, we can calculate the sum of the entries for a job and use this to chart and calculate the actual usage for an entire job or ongoing usage during a job. This can then be charted against the energy target from the job table. Looking at some of our outputs then, an iPad Air, this is at our operator station. An iPad Air 2 will be attached to each printing machine. This will allow the functionality of using fingerprints to log into the system. The system will be configured to show a display depending on the employee's role. It will also log any changes to the press status by the employee who has logged in. Research has shown that this tablet has the capability to support JavaScript, which is going to be important as we try to display information on the screen. Once logged into the tablet, the display will be fairly basic, detailed information. It will show the operational details such as the press ID, the job ID, the order quantity, rejects, and quantity to produce. There will then be a status bar. This will be green when the machine is running and red for when it's stopped. A graph showing the actual energy uses versus the planned energy use, and then a graph showing the current ink usage versus the planned ink usage. At the bottom of the screen there will be a button to enter the change status screen. This change status screen allows the operator to change the status of the press. They will have two choices: either the machine is running or it is stopped. If they choose stop, they must select a reason for doing so. For example, the machine is broken down, there's a changeover taking place, or there is a scheduled break. The system will then log this time and reason for this change, and will also log the employee who initiated it. A home button will then allow the employee return to the operation screen. Our next output regards our reject station. As proposed in the brief, a scale system will be added to each machine. I propose that an iPad Air 2 is connected to this system. Once a QA person decides to reject sheets, they will put them on a scale and log into the system using their fingerprint. There will be a very basic screen available to the QA on logging in, and it will give them two options. They can either reject pages or reset the scales. The reset scales option is to be used when the bin on the scales is being emptied, and then this will be recorded in the system as having happened. If they select the reject pages, they will be taken to a second screen. This screen will allow the QA to reject a number of pages, but it will ask them to select a reason for this. That way, the reason for the rejection will be recorded and will allow further data analysis of it. The reason for the rejection, the time, and the employee's ID, as well as the job number, will be entered into the database if the employee presses the reject button, as well as the current weight on the scales. We move on then to the supervisor station. The supervisor will have a view that shows all of the press statuses, as well as the ink and energy graphs. It will also give the supervisor the ability to create reports regarding downtime and rejects. The system will be built on a hierarchical model. That means that each user will have the ability to view their own screen depending on the role and all of the screens of the people below them in the hierarchical chain. So this allows the supervisor to view the supervisor role, but also to view the QA role or the role of the operator. In the manager station, the manager will be able to view the status of all the printing presses, as well as the ability to generate reports and more expansive reports in a report generation section. Using the hierarchical model, the manager will be able to view his own system, the supervisor system, the operator system, and the viewpoint of the QA. That is the general basic principle behind the system, and now we're just going to take a look at our coding approach. For a HTML and CSS5, this is going to be a web-based application, and as such its structure will be built and styled using the latest version of HTML and CSS. As the system will be used across multiple devices, it will have a responsive design framework. This will be done using CSS properties such as percentages and EMs to control sizes and media queries to ensure that the right device has the right display style. On our client side of the system, we envisage using JavaScript. As research has indicated, JavaScript will be supported on all the devices we intend to use. JavaScript will be used in connection with PHP to generate a number of graphs that will be visible throughout the system. It will also be used to override CSS depending on the choice made by users and entries into the database. The major functionality of this program will come from the server-side programming. The database will hold all of the data that will be built using PHPMyAdmin. The database will then be interacted with using a combination of HTML5, PHP, and MySQLi. The combination of this will be able to dynamically create reports and PDFs depending on users' choices, control the user ability to view the system based on their login, and many more other functionalities. The main code that we're going to use for this is the PHP and MySQLi. The combination of this is a very powerful combination and will allow the data that we have stored to be viewed, manipulated, and given the best chance and most powerful chance to affect the company. That is the basic presentation of my storyboard. It is a simple solution to a problematic and complicated problem. I hope that my solution meets all the criteria that the customer has asked for, and that it is a simple installation process, and that the system itself will work as I have stated. Thank you very much. Goodbye.